Congratulations to finishing your machine learning course. You finished all of the videos now. Now it's time for the epilogue, the final part of the course, where we're just going to recap the whole thing. So first of all, we'd like you to understand what the course objectives are. Again, the idea is that we want to cover the basic concepts of machine learning. We want you to understand when to apply machine learning for a given problem. Not all problems are going to be amenable to using machine learning, but there is a large set of problems that we can use for both supervised, unsupervised, and in some cases, reinforcement learning. These two latter paradigms are going to play a much larger role in the coming years. We also want to make sure that you understand how to evaluate a machine learning solution. There are many ways that you've done this also through the projects, but also in your collab notebooks and lectures. You've learned about various loss functions and various different ways that you can analyze the results through macroscopic analysis like F1 and loss functions, but also microscopic analysis and mesoscopic analysis, which I have asked you to do as part of your projects. Finally, we also wanted you to make sure that you have an experience of using a machine learning tool to carry out machine learning experiments. You've had this in spades, actually. There have been plenty of opportunities for you to do this within your collab notebooks, and hopefully as part of your team project, you have executed machine learning on your own on your data sets that you care passionately about. So with that, we've covered basically all of the core course objectives we hope that you have been able to accomplish this semester. So in addition to the important primary metrics, we also have some secondary learning objectives for you. The first one that we're going to check off is on Python. So whether you're an old hand to Python or new to Python, we hope you've had a pleasant experience using it for your machine learning class. Python is a general purpose, high-level language, but it's particularly adept to you doing machine learning, mostly because of a number of libraries that have been created. So NumPy, Pandas, these are two libraries that underlie all of the foundations for data science and machine learning, but specifically for our course, sklearn, and the deep learning framework PyTorch, which has helped us learn both traditional machine learning as well as deep learning material. You've had ample chance to practice the idea of using Colab and Jupyter notebooks throughout the course. This has been due to the very large sub-team of people working under our staff to help with constructing the Google Colab notebooks that help you practice what you've learned in lecture. So we hope this experience has been very helpful to you, even though there may be some hiccups along the way. Okay? It's a really intuitive way to mix visualization and coding at the same time, and we hope you'll carry this skill on forward into your further coursework and even your professional career. Things are definitely evolving in this space, so I think what you'll see here is just the beginning of a very intuitive and long-term method of doing coding and visualization as well as machine learning. Finally, most importantly for us is that you practice what you have learned. Even if you haven't gotten all of the basics down, you have actually tried to execute a project. Hopefully, with your group mates, you had a chance to instantiate something that you guys all care about and have deployed machine learning and assessed how it works in the wild. Also very importantly to us is the idea that, machine learning doesn't stop just with the math. It happens to be the case that we want our machine learning projects to be a source of human communication for you to learn how to communicate your findings and your execution of your work to others through science communication, both in terms of your videos through to laymen, as well as to other learners, as well as your instruction staff through your presentation and poster. Now, there are lots of things in machine learning, so many that there are impossible to decide what to cover in such a short semester. There are many things that we didn't cover, including theory of computation, and most importantly for us, I think there's one paradigm which we've concentrated a lot on, which is connectionist algorithms. But there's another very large class of Bayesian models, which are very well principled mathematically and definitely encapsulate many of the ideas that we would like to converge connectionist algorithms and strong mathematical frameworks together. So I think you'll see this type of work percolating more into the deep learning and connectionist algorithms that you'll see in the next upcoming years. It's actually a very exciting time to be working in machine learning, and I hope our course is just your first step into this really interesting and fruitful space. So in conclusion, you've had a chance to pick up some basics, so statistics, perhaps you're taking artificial intelligence at the same time. But certainly there are a lot of other courses that you can take, such as expert systems, uncertainty in AI, which goes into Bayesian statistics, AI planning and decision making, which goes more into reinforcement learning, and a lot of other ways that you can employ things, even connecting to computer architecture, such as the general purpose computation on the GPU. But there are lots of other application areas that you can work on. So the recommendation systems, digital libraries, and natural language processing, these are the fields that your lecturer, yours truly, works on, but there are many other areas that can benefit. In fact, there's pretty much no area in society today that doesn't have some inkling about how to incorporate big data insights from aggregating lots of user information to comb and make use of big data. Okay, so you can see this in speech processing, big data analytics, optimization, health informatics, as well as computer vision. So now you've come to the end of the course. Everyone needs to know about machine learning, and now you are positioned to make a difference. You are one of the few people, okay, even in this size of a cohort, that really understands machine learning. And this is just the first step of hopefully a very fruitful relationship that you'll have with this material, and invest more in it so that you understand it better. And again, this area is evolving very quickly, so I think this will be very important for you. I also want to acknowledge the staff of our Fearless CS3244 course. It's really a very large team effort in which your alumni have come back to try to help you. Okay. Now, while the playing field for machine learning from our TAs is varied, I think overall they've invested a huge amount of time. You don't see it at all from all of the staff meetings that we have and the thousands of messages that we send through our Slack channel. But really, let's give a round of applause to all of our TAs that have helped out. We've had instructional staff like myself and Chris involved, but also a whole host of graduate TAs who have been in charge of particular components, like our collabmology with Martin, our projects with Hang Chan, tutorials with Abhinav, exams with Yushen, and student XP from Niyamo. Okay, so all of us have been together in this endeavor, and we have had a really large and expert group of TAs, undergraduates, who have been helping out for the course. So again, let's give them a big thanks for taking very good care of us over this last semester. So that's it for our course. We've come to the end. We have only 2 last videos to show you, one on the exam format. Of course, you already know the exam will be taking place next Monday, okay, on the 9th of November on our normal lecture timing, just like as in exam 1. So we'll have all 3 parts of the exam on those 2 hours. The Zoom proctor rooms will be announced to you later on in the week, and you'll get the password protected exam paper, which you will be able to decrypt during the exam by Sunday evening. It is an open exam. You're allowed to use any notes, any printed materials, any web sources, except for any communication with another learner or another peer, or just people in general while you take the exam. You're allowed to use online calculators of a scientific sort, but please do not open applets or computational sites that can show you how to do backpropagation or calculate information gain. Those are strictly not allowed, okay? Now, we know you can treat this as an adult, and we'd like you to obey the honor code for the course, so please heed these instructions for your own well-being and for the safe and fair execution of our exam for all of our learners. We hope you'll also stay in touch with us. So once you finish this course, keep in touch with us on Facebook. We have an alumni group. Many people come back to the course as TAs, but even after many years, people come back and ask for interns and other things of this sort, and then we can direct them to our current batch of really smart and intelligent students. Okay, so that's all we have for you. I wish you a fond farewell and good luck on your exam for CS3244 and for your other finals that you have in the upcoming weeks. Cheers!